And hours used is the simplest way of keeping track of things. And a lot of, even if they disallow everything else, and our device will tell them how many hours this battery pack was used, because there's always human error. People get, the way these battery packs are used is they're put into a barrel that can handle the pressure that they're going to be seeing while they're downhole. And once they're in there, they all look the same. So they lose track of them a lot. But our device will identify everything with a unique serial number and give the history of it. So after our device is used, they bring it to the surface. They hook it up to their laptop, and they can get a history of what it's seen. It tells you how much energy is remaining in the battery. It tells them what the peak current draw was from the tool and exactly when it happened. If there's a problem, this might help identify when it occurred. What the maximum and minimum temperature of the batteries have seen. We make different battery packs for different applications. Typically, 150 degrees C is what is the industry standard. For normal drilling operations, that's fine. Above that, we make special battery packs that have special cathodes that can handle 165 degrees C and 180 degrees C. The 200 degrees C, which I heard a little bit people talking about, is a bit out of the realm for our customers. They don't feel comfortable doing that, at least while they're drilling. Some wireline services could handle that for a little while, but for drilling, 200 is pushing it. Our batteries could probably handle the right cells, but their electronics and their tool would break down. We tell the customers how many hours their tools are being used. They can set different thresholds. Tools come in all different shapes and sizes. Some of them are power pigs. They draw 500 milliamps. Some only draw 50 milliamps. So they can set thresholds, and it becomes like an hour meter how many hours they were used above thresholds. And also, they get a very detailed history of that battery pack from the day it was manufactured, born, if you want to call it that, to the day they downloaded the data. They get to see how the black line here is the tool drawing current. The green one is the temperature. You can see as the tool goes downhole, temperature goes up, gets used. They pulled out of the hole probably to change a bit, and they go downhole again. And you can see the voltage of the battery pack as time went on, it got older. It couldn't handle the load anymore and started dropping. So this becomes a diagnostic tool, and that's what we're learning. Our customers, when we first started this, really had not much concept of how their tools operated. Often they inherited this tool from another company they bought out, or they purchased it. They don't know too much about it, but this gives them for the first time, they get an idea of what their tool does downhole, how much current it draws, what effects temperature would have on it. And in a lot of cases, it helps them when the tool comes back from the field. They look at the data, and sometimes they'll see current spikes happening for no reason. They tag that tool to investigate more what is causing the problems. So this is what sets us apart from the other battery manufacturers. We don't make just straight batteries, which is what most people expect these days. We add a little bit of brains information to it. And really, it comes into, like I said, a diagnostic source of information for them. And we built upon that by adding to what we developed already. We add a shock and vibration to it. Now our customers could see what is happening in the shock and vibration sense. Because a lot of cases, their tools don't have that built in, doesn't support that. We give them this capability they have to use a battery anyways. Why not get the new technologies which allows you to see shock and vibration? So we allow our customers now to see what happens. And in this case, right here, they had a failure. We could show them that was a high shock and vibration well, and they can go back to their customer now and make them, for example, here's the tool that got damaged. All the bolts, everything got torn apart, and they can go back to their customers and say, it wasn't our fault that we broke, it was your fault. We don't owe you money, you owe us a new tool. And really, and the challenges for us is to make it small, keep the cost down. We like the idea of going to the ceramics. We'll see if we can go there, but at the end of the day, our package is a disposable device. We can't put anything too exotic in there. It has to be reasonable. And our biggest problem is the temperature, and we're always trying to make our devices more accurate, keep crystals accurate, because there's a real-time clock in there. And shock and vibration is something we also learn to live with. And that should be it. Thank you.